this video, I briefly want to show you how to find the derivative of logarithm functions. We already know how to find the derivative of the natural log function, and this is related, but obviously not exactly the same thing. So I have the simplest equation just about that you can come up with here. It's a log base 2 of x. I want to find y prime, okay? The key here is using the base change formula to rewrite this, because I don't know how to find the derivative of the log base 2. I do know how to find the derivative of the natural log function, okay? And remember, you can use the change of base formula. You can either take the log of this divided by the log of this, or you can take the natural log of the top and the bottom. And that second approach is going to be a little bit more useful because we already know how to find the derivative of the natural log. And so we can use something we already understand. So this is the same thing as y equals ln of x over the ln of 2, okay? And this is, it still looks relatively complicated. You're probably looking at it thinking, well, won't I have to find the derivative using the quotient rule or something like that? But it's not going to be that complicated, and here's why, okay? Think about what kind of value the natural log of 2 is. Yeah, the natural log of 2 is a constant, okay? It looks messy, looks ugly, but that's just some decimal, okay? The natural log of 2, if you really care to know, is approximately 0.693, okay? So the point here is that's a constant that can really just be multiplied out, and that means I can take the derivative of 1 over the ln of 2. That's a constant. And then I can just take the derivative of the natural log of x, okay? So I can factor out the constant, take the derivative of the natural log of x, and of course, the derivative of the natural log of x is just 1 over x. Okay, so I have 1 over x coming from that, and it's being multiplied by 1 over the ln of 2, okay? And so it turns out the derivative of log base 2 of x is actually just going to be 1 over x times the ln of 2, okay? And yeah, if you think about this, the derivative of the natural log function is 1 over x. Okay, so, you would kind of expect the derivatives of other log functions also might involve a 1 over x, okay? The only thing it's going to involve additionally is the natural log of the base. And by the way, we've seen this before. Remember, the derivative of e to the x is e to the x. The derivative of 2 to the x is 2 to the x times the natural log of 2. It's times the natural log of the base. And so we're seeing the same thing. It's following the same pattern as the derivative of the natural log function. You're just getting a natural log of the base showing up in the denominator, okay? So your textbook is going to tell you that the derivative of the log base b of x is going to be 1 over x times the ln of b. Again, that ln of b needs to be in the denominator, okay? It's not a super common derivative. It's one of these things you're probably going to see once on the AP exam. You need to have it on a note card, though. Obviously, it'll come up from time to time. Now, you still have to apply the chain rule and things like that. So if I have the log base 4 of 5x, for example, just like if you were taking the derivative of the natural log of 5x, you're going to have the reciprocal of the inside function. So 1 over 5x times the natural log of the base in that denominator, okay? And then the chain rule is always with us, okay? You've got that 5x on the inside there. Derivative of the inside function is going to be 5. That'll show up in the numerator. And just like when you take the derivative of the natural log of 5x, and the 5's cancel and you end up with just 1 over x again, same kind of thing is going to happen here. You're going to get 1 over x ln of 4, even though you had a 5 in your inside function, okay? Now, you don't want to take that too far because you could have other types of situations. So, you could have something like the derivative of, you could have something like the log base 3 of x to the 5th power or something like that. And that's not just going to be 1 over x ln of 3, okay? This one would end up being, remember, the reciprocal of the inside function, so just like the natural log function, okay? Times the natural log of the base, and so you'll have the natural log of 3 in there. And then you've got to multiply by the derivative of the inside function, which is going to be 5x to the 4th. And then stuff's going to cancel. 4 of these will cancel 4 of those. You'll end up with 5 over x ln of 3. Okay, so this one does end up with a 5 on top. By the way, that's not the way I would do that problem. I would use my log rules. You can peel that 5 off and you can bring that out front. And actually, if you bring it out front, it's a constant, you can factor it out of your derivative. And you're really just taking 5 times the derivative of the log base 3 of x. Derivative of the log base 3 of x is going to be 1 over x times the ln of 3, and then you're multiplying by 5 out in front, and that's going to end up giving you a 5 in the numerator. So a much faster way to do it, all right? So not the world's most common derivative rule, but it is one you're going to see from time to time, and definitely one that you need to know.